This is an MCQ from Kinematics. There is a solid disk of radius r which is revolving on a horizontal surface without slipping with angular velocity of omega and angular acceleration alpha. The question is, what is the magnitude of the acceleration of the point of contact? Okay, so if a is the acceleration, then what is the magnitude of the a? Without going to any calculation, I'd like to give you a logical solution to this question. Okay, before going to the question, first let us consider two cases. Case number one, suppose this is the disk and I have made a hole at the center of the disk with some suitable operation like punching, and I have mounted the disk onto a stand so that the disk may revolve around the stand. Okay, the stand is the axis of the rotation. Okay, so once the disk is rotating about the stand, what is the velocity and acceleration of the center of the disk? It is 0. Omega is also 0, alpha is 0, and also v is 0, a is also 0, right? Now let's suppose this stand is at the periphery. Okay, so like suppose this is the disk and I have made the punching at the periphery. Okay, okay, suppose this is the stand and the disk is revolving like this. Okay, like this. So the disk is revolving around the stand when this point at the periphery is fixed. So in this case, if you can realize, so what is the velocity and acceleration of the center of rotation? In this case also omega will be 0, alpha also 0, right? v0, a0. There is no question of linear displacement and linear velocity. So linear velocity is 0, linear acceleration also 0. So now come to our question. See, when any point on the periphery of the disk is coming in contact with the surface, it is at rest. As long as the point is in contact with the surface, it is at rest. And if you can imagine, the disk is revolving, resting on this point, right? The disk is rotating depending on this point, resting on this point, right? So as long as the point is in contact with the surface, it is at rest. So the velocity and acceleration of the point of contact is 0, right? So the answer A is